Before we draw cost curves, let us revisit the short-run production curve because there is a very intuitive link between both the curves. The short-run production function from table is plotted in graph. Recall from initial discussion that the initial region of upward curvature, that is, L is greater than 0 and lesser than 4 of the production function corresponds to increasing returns to the variable input. Beyond the point L is equal to 4, the production function exhibits diminishing returns to the variable input. Not surprisingly, the shape of the variable cost curve is systematically related to the shape of the short-run production function. The connection arises because production function tells us how much labor we need to produce a given level of output, and this quantity of labor when multiplied by the wage rate gives us variable cost. Suppose, for example, we want to plot the variable cost of producing 58 units of output. We first note from the production function that 58 units of output requires 5 units of labor, which at a wage rate of $10 per person hour gives rise to a variable cost of 5 multiplied by 10 is equal to $50 per hour. So, graphically, the output level of 58 is plotted against a variable cost of $50 per hour. Similarly, note from the production function that 43 units of output requires 4 units of labor, which at the $10 wage rate gives rise to a variable cost of $40 per hour. In like fashion, we can generate as many additional points on the variable cost curve as we choose. Of a particular interest is the relationship between the curvature of the production function and that of the variable cost curve. Note in production function graph that L is equal to 4 is the point at which diminishing returns to the variable factor of production set in. For values of L less than 4, there are increasing returns to L, which means that increments in L produce successively larger increments in Q in that region. Put another way, in this region, a given increase in output Q requires successfully smaller increments in the variable input L. As a result, variable cost grows at a diminishing rate for output levels less than 43. This is reflected in graph by the concave shape of the variable cost curve for output levels between 0 and 43. Once L exceeds 4 in production function graph, we enter the region of diminishing returns. Here, successfully larger increments in L are required to produce a given increment in Q. In consequence, variable cost grows at an increasing rate in this region. This is reflected in the convex shape of the variable cost curve in the graph for output levels in excess of 43.
Really an intuitive way to derive the link between variable inputs and its cost. But what about fixed cost and total cost of production?
Because fixed costs do not vary with the level of output, its graph is simply a horizontal line. Figure shows the fixed, variable and total cost curves FC, VC and TC for the production function shown in figure. Note in the figure that the variable cost curve passes through the origin, which means simply that variable cost is 0 when we produce no output. The total cost of producing 0 output is equal to fixed costs, FC. Anyone would always have to incur FC even while no output is produced. Note also in the graph that the vertical distance between the VC and TC curves is everywhere equal to FC. This means that the total cost curve is parallel to the variable cost curve and lies FC units above it.